What's up, guys? This is Waleed, and today's problem is the uranium-235 fission. So they gave us this They gave us this equation, the chemical equation of what's going to happen fission, and they want to ask us what's the energy released in this fission. Okay, so they gave us in here that the atomic masses of each one of these guys in here. Those guys, three guys. So basically, the summation of these two right here is going to be less than this guy because there's going to be energy released from the loss of mass. Okay, so from there we can multiply it by using the equation E equal delta m c squared, and then from there we can find the energy. So we just need to find the delta m. Okay, so delta m will be equal to, we need to find the mass of the atomic mass of the U235, which is here. So 235.0439, and then we add the neutron to it. Bear with me, guys, I'm a little bit sick, so my voice might be too boring or annoying. Minus the mass of these guys, which is 143.9229 plus 89.91 minus 2 times 1.00867, because we have two neutrons. And then we close this guy. So from here we got 236.052 minus 235.859. So the mass you'll get, delta m, will be equal to 0.19281 atomic mass. Okay, so from here we substitute this guy in here and we change it to MeV, so 0.19281 U multiply times, to change it to MeV, multiplied by 931.5 million electron volt. This is U. So each one atomic mass is going to equal this amount, and it's divided by c squared. Let's close this guy. And then times c squared from here. So we take these guys out and we get 179.6 million electron volt. So 179.6 million electron volt. Another example of the possible results, we do exactly the same thing we did right here. Okay, so 236.0525, because both of them has the same thing, this guy and this guy, and then minus no كمان شوي هلا بنزل. Excuse me, guys, that was my mom. So minus, and you do the same thing, you add the masses from these, and don't forget that these have 3 neutrons, so multiply times that 3, and then when I add all these guys together, 235.86703, and then delta m will be equal to 0.18554. This usual is going to be negative, those guys are going to be negative. That means the fission is going to release energy. That means, so it's minus in here, but don't worry about this. So E is equal mc squared, which is equal to 0.18554 U 931.5 million electron volt. This is U, this is c squared times c squared. Therefore this guy I got 172.83051. Let me write it right here, 72.83051. So now they're asking us how many gallons we need to burn in order for us to like get the same energy when we fission uranium-235, 1 kilograms of uranium-235. So they told us that, let's say that the average of 235 with the two fissions we have right here, this one, the average of those guys is what is it per reaction, per one fission reaction, okay, per nuclei. So the average is going to be equal to 179.6 plus 172.83 divided by 2 to find the average, so it's 176.215. Okay, so let's find this is million electron volt, so let's find it in joules. So 176.215 times 10 to the 6, which is a million electron volt, and then multiply by 1.6 times 10 to the negative 19 joules divided by electron volt. Okay, so we can take out the electron volt, equal 281.944 times 10 to the negative 13. That's in joules. That's fission per nuclei. Okay. So now we need to find how many nuclei or molecules are in 1 kilograms of uranium-235. So 1,000 1 kilogram is 1,000 grams, and this one is always in grams. And then divide by 235.05, which is grams per mole for uranium-235. Man, I have a problem with saying freaking uranium. Times 6, the Avogadro number, 0.022, times 10 to the 23. This is molecule per mole. So we can cancel all of these units, and we're left with molecules. So we get 2.56 times 10 to the 24 molecule. Okay. So from here, we find that we need to find what's the total energy. So we have how many molecules, or how many molecules are going to go during the fission, and then multiply it times the energy per fission. So 281.1.944 times 10 to the negative 13 joules, multiply it times 2.56 times 10 to the 24 molecule. So we get the total energy now, so it's 7.2234 e to the 13 joule. So if you look back at the question, they give us how much per gallon is the energy released when burned. So they want how many gallons this is equal to. So we just divide 7.2234 e to the 13, so the total gallons, divided by the 2 times 10 to the 8. Was it 10 to the 8? Yeah, 10 to the 8. Joules per gallon. And this is joules, so we cancel those out. And for this guy, I got, let me do the math. 27722 divided by 2e to the 8. So for this guy, I got 361,171.40 gallon. Alright guys, hope this helped. Thanks for bearing with me. Good luck, bye.